Hello student. In today's lecture we are going to learn about the some basics of electrochemistry. Here we understand that whenever we talk about the electrochemistry, we deals with electrochemical cells. Now if I ask you what do you mean by electrochemical cells, then electrochemical cells are those cells in which the conversion takes place. It means that there's a two types of conversion taking place. One is between electrical to chemical energy, and the second is between chemical to electrical energy. So these two conversions of energy takes place in these cells. So accordingly, there are two different types of electrochemical cell. One is called as, I just write over here, okay, there are two types of electrochemical cells. Okay, one is called as galvanic or voltaic cell, galvanic or voltaic cell, and other is called as electrolytic cell. Other is called as electrolytic cell. Okay. Now, as you know that in this chapter we have two forms of energy. One is chemical energy and other is electrical energy. And we are going to learn only about these two energies and their conversions and their interconvergence. So in a galvanic cell or a voltaic cell, the type of conversion which is taking place is from chemical energy to electrical energy. From chemical energy to electrical energy. So I can say that in these types of cell, we get a electricity because our end product over here is electric energy we are getting over here. So we are getting electrical energy over here. So I will say all our electronic gadgets, they all are run on these galvanic or voltaic cells because they provide us with the electricity. Okay, so electrical energy. Okay. On the other side, if you see, the electrolytic cell undergoes conversion of electrical energy to electrical energy to electrical energy to chemical energy. So I will say that here we get a pure chemicals. In a electrolytic cell, we get a pure chemicals. Like we get a pure NOH or a pure fluorine or maybe a pure sodium or a pure chlorine. So we say that in the electrolytic cell, we get a pure chemicals, or you can also call it as chemical energy. Okay. Now suppose if I do the distinguish between these two different types of cells, so I will say, okay, my first point will be the one which I have just now written. Okay. Now let us understand the second point of distinguish between these two types of cell. Now in a galvanic or a voltaic cell, if you see that here there is a spontaneous redox reaction takes place. That is what a spontaneous redox reaction takes place. Spontaneous redox reaction takes place, and here non-spontaneous redox reactions takes place. Non-spontaneous redox reaction takes place over here. Now, as you know that redox reaction plays very important role in electrochemistry, and you should understand, okay, what do you mean by redox reaction? Redox reaction is a combination of two reactions, which is oxidation and reduction reaction. These reactions are taking place at each of the electrodes. There are two electrodes in these cells. At one electrode, oxidation takes place, which is called as oxidation half reaction, and at other electrode, reduction takes place, which is also called as a reduction half reaction. Understood? So whenever you add both of these reactions, that means what, oxidation and reduction reaction, when you add them together, so the overall reaction that we get, that is called as what, the redox reaction. So in case of galvanic and voltaic cell, galvanic or voltaic cell, the reaction which is taking place will be spontaneous redox reaction. Why? Because suppose if we consider Daniel cell, then Daniel cell is a simple copper. Daniel cell is a simple zinc copper cell. Daniel cell is a simple zinc copper cell. Now suppose I just show you the construction of this cell so that you can understand in a much better way. Suppose in the case of a galvanic or galvanic or voltaic cell, you have to first prepare the half cells. Understood? So how to prepare this half cell? It is very simple. What you have to do, you take a metal, you take any metal, and then you dip in a solution containing its ion. For example, I choose over here is zinc. Suppose I take a zinc metal and I place it in a solution containing zinc ion. So hence this become a zinc half cell. This become a what? Zinc half cell. Means here the condition is that you must bring the metal in a direct contact with its ion so that they can undergo interchange. Means they can undergo oxidation also and reduction also. Getting it? So whenever they are not attached with anything, when they are independent, they have both the capacity. That is, they can undergo oxidation also and reduction also. For example, I just show you over here. Suppose if I have a zinc atom and if a zinc atom converts into zinc ion, then it has to lose 2 electrons. So when it loses 2 electrons, I will say this reaction is what? Oxidation. Similarly, this electrode is also capable of undergoing reduction reaction. So if you consider a reverse reaction, that is zinc ion taking 2 electrons and will become a what? Zinc atom. So this reverse direction reaction is called as what? It's a reduction. So before a electrode, if it is not attached with anything, if it is independent, we say that it is having both the capacity, it is having both the capability that it can undergo oxidation as well as it undergoes what? Reduction. Similarly, if I suppose draw over here is copper half cell. So how I can make a copper half cell? I take a copper electrode, and I will dip in a solution containing what? Copper plus 2 ion. Getting it? So in this way, copper also undergoes both the reaction, oxidation as well as what? Reduction. I can write like this: copper atom undergoing what? Copper ion formation, and this will be an oxidation reaction because it has to lose 2 electrons. And I will say that the forward reaction is oxidation and the reverse reaction is what? Reduction. Understood? Now what happens when you want to make a Daniel cell? Then you have to combine these two half cells. So when you combine them, it means that when you link them together, so you have to connect them in a 2 ways. One thing is that you have to connect both of these 2 electrodes. So suppose I connect both of these 2 electrodes with a wire. So in this way, the 2 electrodes get connected with each other. Then in another way, what I have to do, I have to connect both of these two solutions with a salt bridge. Now salt bridge provides a connection. Salt bridge provides a contact between the two solutions of the half cells. Understood? So when I connect them, then what happens? The zinc electrode will become negative electrode. The zinc becomes what? Negative electrode. Now why it becomes negative electrodes? Because it has been found that zinc is having greater tendency to undergo oxidation. Zinc is having greater tendency to undergo what? Oxidation. Means if you compare the zinc oxidation potential, if you compare the oxidation or a standard oxidation potential of zinc, you will find that the oxidation potential of zinc is greater than the copper. So it means that out of these two, who is having more tendency to undergo oxidation? It is zinc. Therefore, when you connect zinc and copper together, then you have to place zinc on the left hand side. Why? Because the one which undergoes oxidation will always kept at the left hand side. Understood? And what do you mean by oxidation? Oxidation means loss of electrons. So I will say that at this electrode, the electrons are formed, the electrons are produced. So wherever the electrons are produced, that electron will become negative. And wherever oxidation takes place, that electrode is called as anode. So hence, in the galvanic or voltaic cell, the negative electrode is what? Anode. Because always you have to remember that wherever oxidation takes place, always there will be that electrode will be called as what? Anode. Getting it? Now, these electrons which are formed over here, they will travel through this wire and they will reach to the other electrode. And when these electrons approaches over here, then you will find that at this junction, at this interface, the copper ions are gathered over here. The copper ions are gathered over here. From the solution, all the copper ion will accumulate over here, and they are just waiting for these electrons to come. So as soon as these electrons come, this all copper ion will accept the 2 electrons, and they will get reduced to copper atom, and they will get all reduced to copper atom. So here the copper is having more tendency to undergo what? Reduction. So hence when you combine them, when you combine the 2 electrodes, then both of these electrodes are having a different capacities. They are having a different abilities. One is having higher potential towards oxidation and other is having higher potential towards what? Reduction. So the one which is having a higher potential towards oxidation will be always placed on the left hand side, and the one which is having higher tendency to undergo reduction will be always placed on the right hand side. Understood? So here I will say that copper will undergo reduction because the SRP value, that is what the standard reduction potential value of copper is greater than compared to a what? Zinc. So hence I will say that at the positive electrode, what happens? The copper ions will accept the 2 electrons and it will undergo reduction to form what? Copper solid. Understood? So at this electrode, you know what happens at the zinc? This will undergo corrosion because the mass of this electrode is reducing because it is getting dissolved into the solution. But on the other hand, the mass of the copper electrode will increase because here the copper ions are deposited and copper atoms are formed. So this electrode will become a fatter. It will become a stout. Getting it? Okay. So here there is also a formation of the difference in the concentration because here the zinc ions are produced and here the copper ions are what? They are consumed. है ना? यहाँ पे जिंक आयन क्या हो रही है? फॉर्म हो रही है. देख रहे हैं आपको? यहाँ पे रिएक्शन में जिंक आयन क्या हो रही है? फॉर्म हो रही है. और यहाँ पे कॉपर आयन क्या हो रही है? कंज्यूम्ड हो रही है. तो यहाँ पर जब जिंक आयन फॉर्म हो रही है तो ये जो लेफ्ट हैंड साइड का जो इलेक्ट्रोड है उसका जो सोल्यूशन है उसमें पॉजिटिव चार्ज इंक्रीज होते जाएंगे. मतलब ये जो सोल्यूशन है इट विल बिकम पॉजिटिव चार्ज एंड दिस सोल्यूशन विल बिकम व्हाट? This solution will become what? Negative charge. Understood? So hence I can say that in the case of zinc half cell, the electrode is negative, but the solution is what? Positive. But in the case of copper electrode, the electrode is positive, but the solution is what? Negative. So in this way, in order to neutralize this polarity, here the ions will move. Here the ions will move, means here the positive ion will travel towards the negative pole of the solution and the negative ion will travel towards the positive poles of the solution. So in this way the electrical neutrality has to be maintained by flow of the by the flow of the ions through the salt bridge. And on the other side, on the wire, the electrons will move from negative to positive, and the current will flow from positive to negative in this direction. Getting it? So in this way the whole circuit will be completed, and as soon as you put a bulb over here, then this bulb will start glowing. This bulb will start what? Glowing. And hence we can say that the chemical energy has converted into a what? Electrical energy. So hence we have understood that how the galvanic or a voltaic cell works. It works in this way. There are 2 half cells and each of these half cells are, first of all, they are independent, but when you connect them, then you have to place them according to their potential. And hence in this way, when you connect them internally as well as externally, then a complete cell is been formed. And in this way the reaction will be going to take place. Okay, so this reaction is called as what? This is a oxidation half reaction, and this is a this is the oxidation half reaction, and this is the what? Reduction half reaction. This is taking place at anode and this is taking place at what? Cathode. Okay, so when you add both of these 2 reaction, you'll get an overall reaction. Suppose I just add them together. Okay, so just I add them together. See what overall reaction we are going to get. We will have zinc atom converting into a zinc ion and releasing 2 electrons. Okay, this is aqueous. On the other hand, the copper plus 2 ions, okay, they accept these 2 electrons and undergoes reduction to form what? Copper atom. Okay, so when I add this to the reaction, which is a half reaction or half cell reaction, then 2 electrons are common and they will get cancelled. And what do we get? We get zinc solid plus what? Copper plus 2 ion. Okay, reversible sign. Forward reaction will be a discharging reaction. Will be a discharging reaction. In the reverse reaction will be a charging reaction. Okay, it means when the cell works, it will undergo discharging. And when it is reached to the lower potential, when the potential drops, then you have to recharge it. So while recharging, the reverse reaction will take place. Okay, so in this way, we will get on the right hand side zinc plus 2 ion aqueous and plus copper solid. Okay, this is the overall reaction, and this reaction will be called as redox reaction, and it is a spontaneous redox reaction. There is no external influence. Getting it? It takes place by itself. As soon as you bring the zinc into a direct contact with the zinc ion, it will undergo readily oxidation. And similarly on the other side, the reduction will take place by itself. So it is a tendency which is a natural tendency found. Okay, so in this way we say that in galvanic or voltaic cell there is a spontaneous redox reaction taking place. That is the what spontaneous redox reaction taking place. Understood the meaning of spontaneous redox reaction? Now we move to the other side and we see that how the non-spontaneous redox reaction takes place in the case of what electrolytic cell. Suppose I consider the electrolysis of fused NaCl. Fused NaCl. Fused means molten. Molten means semi-solid or in the liquid form. Okay. Now here, now see, in the case of galvanic cell, we have two different half cells which are separated from each other. But in the electrolytic cell, we have only one single vessel in which both of these two electrodes are connected with each other. Both are present in the same vessel. They are not separated. So hence they are lying in the same electrolyte. They both are lying in the same electrolyte. Only the thing is that you have to connect these electrodes to the external terminals. Like for example, the left hand side electrode is connected to the negative end of the terminal, and this is connected to the positive. So one which is connected to the negative, so this electrode will become negative electrode, and this electrode will become what positive electrode. Understood? Now the electrolyte which is present over here is what NaCl. Now this NaCl initially is in a solid state. It is in a solid state, but when you heat it, okay, when you heat it, it will convert into a what NaCl liquid, and as soon as it turns into a liquid, it will undergo dissociation and produce Na plus ion and what Cl minus ion. Now afterward, when what happens when you on the current, when you on the button, at that time what happens, this electron will become negatively charged and this electrode becomes what positively charged. So due to which what happens, this electrode becomes a poles, and they will start attracting the opposite ions. So the negative electrode will attract what, the positive ions. So you will find after some time all the positive ions get aggregated, they gets accumulated over here, Understood? Okay. And similarly on the opposite side, on the opposite electrode, which is the positively charged, so there all the chlorides ion will be accumulated, over here. Now see, after these ions after they get migrated on these electrodes, what happens, then the discharge reaction takes place. Now if I ask you, okay, what happens at the negative electrode? This negative electrode has attracted whom? It has attracted the sodium ions, which is a positively charged ion, which are also called as cations. So at the negative electrode, what happens? The positive ions get assembled over here, and this positive ion will undergo discharge reaction. Discharge means it will lose its charge. It will loses its charge and convert either into a atom or into a molecule. That depends that what its natural form is there. क्योंकि अगर देखिए सोडियम आयन है और वो मेटल है सोडियम, तो आपको मालूम है कि सोडियम जो है वो मेटल है, तो मेटल विल बी ऑलवेज इन द एटॉमिक फॉर्म. So hence sodium ion will take one electron and it will form what? Sodium metal, right? So in this way, we have seen over here that sodium ion has taken one electron. So gain of electron is called as what? Reduction. So sodium ion undergoes reduction, and wherever reduction is taking place, that electrode will be always called as what? Cathode. And on the other side, what happened? On the other side, at the positive electrode, what happens? Which reaction will be going to take place over here? Positive electron will going to attract the negative ion, which is what? Chloride ion. This chloride ion will lose electron. And the stable form of chlorine is a diatomic molecule. So it will be appearing in the form of chlorine molecule, that is what? Having Cl2 formula, plus it will going to lose 2 electrons. So in order to balance this equation, we have to take 2 chloride ion. So now this equation is balanced and it is an oxidation reaction. So wherever oxidation takes place, that electrode we call it as anode. So this will be my anode, right? Now again, if you see, okay, the number of electrons should be same, because the electron circulate will be a similar. The number of electrons should be always same. So hence what we find that our cathode half reaction or our reduction half reaction is having only one electron. Therefore, in order to make the number of electrons equal, we have to multiply this equation by 2. So what do we get? We get 2 sodium ion. We're taking 2 electron to form 2 sodium atom. So now we can able to add them. So when we add them, what happens? This 2 electrons and this 2 electron, which is common and lying on the opposite side, will get cancelled. So finally, we get this equation, that is what? 2 sodium plus 1 ion Okay, 2 sodium plus 1 iron, okay, plus what, 2 Cl minus ion undergoes what, redox reaction, and this is the outcome. This is the product that we get. We get a pure sodium. We get 2 moles of pure sodium solid at cathode, which deposits at cathode, and plus simultaneously, what do we get? We get liberation of chlorine gas. Okay, this will be liberated. This will be deposited, and this will liberates at anode. Okay, now this reaction will be called as what, redox reaction, and this redox reaction will be non-spontaneous. Now see, initially I have told you, okay, why this is called as non-spontaneous. Why? Because this reaction takes place only when you pass the electricity. Unless you don't pass the electricity, the reaction will not take place. So hence this reaction, this redox reaction is non-spontaneous. So have you understood the meaning of these two cells? One is called as galvanic or voltaic cell, another is what, electrolytic cell. Okay. So with this we end here today. We'll meet again in the next lecture.